All right, now this part is for G period only. We want to calculate the force of attraction between Mercury and the Sun. And I'm sorry, this should say Mercury right here. So let's go ahead and get that force. So that force is going to be G, mass of the Sun times the mass of Mercury divided by their distance squared. When we plug in our numbers, that's 6.67 times 10 to the negative 11th times mass of the Sun times mass of Mercury. And then we'll divide this by the distance squared, which is 5.8 times 10 to the 10th squared. When we work this out, this is going to work out to about 1.2 times 10 to the 22nd newtons. Now we want the speed of Mercury as it orbits around the Sun. Let's be careful. So we're going to have the force of gravity acting on Mercury, and the effect on Mercury is that it orbits the Sun in roughly a circle. So on the left side, that's G, mass of the Sun, mass of Mercury, over Mercury's distance from the Sun. And on the right side, it's mass of Mercury times V squared divided by the distance that Mercury is from the Sun. Now notice a couple of things. The mass of Mercury actually cancels out from the equation. Also, one of the r's cancels. So we can actually isolate V as the square root of G times the mass of the Sun divided by Mercury's distance, so that when we plug in our numbers, times the mass of the Sun, which is going to end up being 2 times 10 to the 30th, and we'll divide this by the distance, which is 5.8 times 10, 5.8 times 10 to the 10th. All of this under a square root. And this actually ends up giving us a V of about, when I round it up, 48,000 meters per second when I round it. All right. Now for question number 3. Earth has a mass of 5.88 times 10 to the 24th kilograms. We want the orbital distance and speed of a geosynchronous satellite. So let's get the orbital distance. So once again, we have the gravity force acting on a satellite, and the effect is that that satellite moves in a circular orbit around the center of the Earth. So that's going to be G times the mass of the Earth times the mass of the satellite divided by the distance squared equals mass of the satellite times V squared divided by R. And one thing is, one of the mass of the satellite cancels, one of the R's cancels. Now we get a problem. We don't have V directly. That's what we're solving for. So when we move in a circle, let's just refresh our memories. Here's the Earth. We're moving in a circle. And since we're moving at a steady speed, not a steady velocity, a steady speed, the speed is going to be equal to the circumference divided by the time. That's going to be 2 pi r divided by the period. Make that a little lowercase r. So what that means is our formula gets modified, G mass of the Earth over r squared on the left side. And that's going to be equal to V squared, which is 2 pi r over t. And then we're going to go ahead and square that. So we're almost where we need to be with this. And I'm sorry, this is only 1, it's not squared. Now what we're going to do is we're going to multiply out what we've got. So we've got G times the mass of the Earth equals 4 pi squared r squared over t squared, and I've got this one little r down here. We're almost where we need to be. So let's plug in some numbers. And actually, first let's isolate. Let's get r on one side. So we've got g, mass of the Earth, over 4 pi squared times the t squared on top equals r cubed. So let's look at the numbers we need to plug into this formula. G is going to be 6.67 times 10 to the negative 11th. Mass of the Earth is going to be 5.88 times 10 to the 24th. The period, that's the time it takes a satellite to go around the Earth. That's 24 hours, but we need it in seconds. So that means t is going to be equal to 24 times 3600. So putting all those numbers in, we're going to say 6.67 times 10 to the negative 11th times the mass of the Earth, which is 5.88 times 10 to the 24th, divided by 4 pi squared, and then the time squared is going to be 24 times 3600. That quantity, well, yeah, let me try that again. So 4 pi squared, and then this is going to be 24 times 3600 squared. All of this is equal to r cubed, the radius, the distance cubed. So to isolate r, we're going to take both sides to the 1/3 power. And when we do that, we're going to end up getting r equal to, when we round it, 42 million meters, or if you prefer, 42,000 kilometers. And this is rounded. All right, so that's the second to the last page on the practice test, and I'll do the last page in the last video.